Hello and welcome to Samsung. In this video, I want to talk about a very important topic of broadcast and multicast handling when it comes to wireless LAN networks set up by the Samsung controllers and the Samsung access points. Now, it's very important that we understand how the controller and the APs handle broadcast. In large networks, broadcast and multicast packets have the capability to create a lot of issues if you're doing a lot of streaming in your network. And network administrators have to come up with ways to control the broadcast traffic in the network so that it doesn't bring the rest of the applications down. So that being said, let's look at what we have on the controller side, which what kind of hooks we have on the controller, which kind of restrict the way we forward the broadcast packet onto the from the wired network to the wireless network. All right, so as you can see here, there is a nice diagram here which depicts there is a wired network and that connects to the controller, and if it's a wired PC on a 10.10.10 network which sends a broadcast which is then received on the controller has to now make multiple copies of that broadcast and then send it over the capback tunnel to all the access points where you have stations on that same network. So if I have a /24 and if I have stations all across my network on different access points, I have to make one single copy and send it to all the access points where all these stations are. And if this is just one broadcast packet, now if you have so many broadcast packets going on, the AP has to make multiple copies, keep doing this over and over again. So it takes a lot of processing. So that being said, by default, what we have done is on the controller, if you go in to the configuration main general, you would see a broadcast multicast filtering setting here. By default, broadcast forwarding and multicast forwarding is disabled. So what that does is it does not forward the broadcast messages except for if it's a DHCP request or if it's a DHCP request and the controller is handling of DHCP, we do accept the broadcast packets. Or if it's an ARP which comes in, for a wireless station. And the next thing I want to talk about is ARP, as to how how actually the controller handles ARP. And after a few minutes, I'll talk about what even if you have to turn on broadcast forwarding or multicast forwarding, what does ACL rule signifies. So let's look at how the controller handles ARP packets. So here's there are two different ways of ARP processing. One is what we call a suppression, where we convert the unicast ARP and deliver the broadcast ARP to the wireless station. So you can see here the wired PC on a layer 2 switch sends a broadcast ARP to the controller, and the controller turns around and sends it to the wireless station over the RF network. So through the capback tunnel, it sends it to the AP, and then the AP actually sends it. So this is the suppression mode. In proxy mode, the APC turns around and does an ARP proxy, meaning it responds if it has a MAC address. So if a wired PC sends an ARP request, the controller, instead of sending it over the capback tunnel and sending it all the way on the RF, it turns around and responds to the ARP message itself. So you don't have to send it all the way back. And the default operation is suppression. So, if you go here, you can change that from general, I believe it's a network ARP. And you can see here, the default is set to suppression. And then you can change it to proxy if you like. So, for the most part, I've kept it suppression all along, but if you feel the need to change it to proxy, you do have the option right here. So that's how the controller handles ARP. Now, apart from these broadcast and multicast settings, there are other settings which apply to the wireless LAN itself, to the SSIDs itself. And those are separate. They're not, they're mutually exclusive. They're not related to each other at all. So I want to talk about IGMP snooping here for a minute because multicasting is becoming more and more prominent in enterprise networks and in almost all networks. That is because of the advent of streaming. There's a lot of streaming content going on, and it is extremely essential that the devices like the controllers are kind of optimized to handle multicast traffic because they can generate a lot more traffic, which in turn relates to a lot more traffic on LAN, also a lot more channel utilization in turn on the RF, and you want to avoid that as much as you can. So the way the controller, the optimal way of doing it is turning on what is called as IGMP snooping. For those of you who are familiar with multicast, IGMP is the group protocol that is used to announce to the network what multicast traffic you'd like to subscribe to so that you can receive those packets. So IGMP snooping is something which we can turn on the controller, and at that point, the moment you turn it on, the controller listens to the IGMP messages that go on in the network and keeps a table of the multicast groups that are part of the that go through the controller. So let's look at this example here. It describes it in very good detail. So you have a station here, and you have a station here, and then you have a station here, and all of them are part of the same network. All right, but only station PC1 and the one on AP2, they submit the IGMP report, and the APC manages the multicast group, so it knows that AP1 there's a station who's subscribed to this multicast group, and AP2 there's a station, but AP3 there's no station. So whenever it receives a multicast packet that comes into it, the controller then turns around and sends it to only those devices that are in the list. That means it does not turn around and broadcast it to all the access points. But if you don't do it, that's how that's how the controller is going to be handling it. You broadcast it to all access points. Now imagine if you have a big scale of access points out there, and you're sending like so much multicast traffic on it. It's not an efficient way of doing it. So this is the right way to do it. Now again, the setting for IGMP snooping on the controller is right here. So what you're going to do is you're going to come here into configuration, and you're going to go into multicast. You're going to turn on IP multicast, enable. You're going to come in here to PIM SM. You're going to select the interface on which you want, for instance, if you know a particular VLAN, that is where you like as a network administrator, you know which VLAN or which interface you are going to receive these multicast messages on. You can specify those interfaces, and the next thing is you turn on IGMP snooping, and you specify which interfaces you want to keep them enabled, and make sure that the M route is selected as well with the interface name of that particular VLAN. So it's a line by line configuration. You come here, turn on multicast, come here, select PIM SM, so that PIM. I'm not going to go into the detail of it's a multicasting protocol, sparse mode, and the folks who are familiar with multicast would be familiar with this. We don't support dense mode. Sparse mode is supported. So it does a very good job of figuring out building that table of all the multicast groups and where those belong. So it knows which wireless stations have subscribed to which particular multicast group. So once that is done, this thing takes care of handling the multicast. So by default, it's always a good idea to turn off broadcast and multicast forwarding, because this pertains to the multicast packets received on the wired side. And then this pertains to more like let this part of the controller take care of multicast handling. You do not want to send so much broadcast and multicast all coming in from all the wired devices to the controller and sending it out on all particular cap wrap tunnels. It's a lot of work. Now, another thing that we need to keep in mind is when you do this configuration with IGMP, it also goes hand in hand with another configuration which is on the wireless LAN itself. And that configuration is something I spoke about when we were configuring wireless LANs in our one of the previous videos. And that is a setting called multicast to unicast. Okay. These two settings, so multicast to unicast and multicast packet discard, are associated with IP multicast being turned on with IGMP snooping. So what it does is to give you an example, I have a diagram here. Let me go back and see where the diagram is. Okay, it's right here. So what it does is when a multicast packet is received, it will it will just turn it into a unicast message and send it to only those stations that have asked for it, and then it would discard the original multicast packet that it received. So think about this. Instead of, if you don't have multicast packet discard, the original packet comes in, and you turn the multicast into a unicast and send it to the receiver, and you also send the original multicast packet, and that's a duplicate packet. So these two go in hand in hand. You always have to make sure that if you turned on multicast here in this option, one of the, like the IGMP snooping and stuff, you better turn on multicast to unicast, so that you're not sending a multicast packet over the RF. You're actually sending it as a unicast packet just to that station, and you're discarding the original packet. That is, two packets are not going on in the network. So the recommended setting is turning on IP multicast and multicast unicast enable. So that takes care of that. These two things go together. Then the the setting here, which is broadcast to multicast, is more to do with traffic received from the wired side to the controller, and whether or not it should forward it or not. So it is recommended that to handle multicast, we turn this feature on, and to handle broadcast, we always disable it. And if you still want to enable it, because there are things like Chromecast and all these devices that are out there which do pairing, that may require the broadcast to be turned on. And in that case, you may have a TV on the wired side, and you have a tablet which is trying to do Chromecast on the TV. In that particular case, or you may have a smart TV which is on the wired side. I'm not talking about Chromecast is on Wi-Fi, but you have a smart TV on the wired side, and you have a tablet on the wireless side, and things along that line, and that particular instance requires that that VLAN requires multicasting, so you can create a broadcast ACL role. So the way to do it would be, you come here, there's an option right here. So you create an ACL with just that particular network. So let's say 10.10.10 network. You know that that network has to see a broadcast. So you say protocol UDP, specify the address like this, and that becomes your ACL, and that gets applied to the broadcast to the broadcast ACL rule. So again, to create ACL, we come here to security, IP ACL right here, and we'll create a broadcast ACL with just that network. Again, the subnet mask has to be 255, 255, 255, 255. But that's all there is to it. And once those two features are enabled, you will so now that you know how broadcast and multicasting works and how the controller handles it, you can more prudently enable these features. And my recommendation is, if you can avoid it, if you can just keep it disabled by default, that's just perfect. But unless you know that there's going to be a lot of streaming and there's going to be a lot of pairing between tablets and there's a lot of airplay going on in the network or something like that, you have to come in and make those changes. Now, another setting that we have to look at for multicast and broadcast, which is again mutually exclusive to what all we just discussed, is the multicast and broadcast handling at the AP itself. So here there are two settings: broadcast forwarding and multicast forwarding. Now, those operate at a WLAN level, meaning at the WLAN interface, WLAN radio interface on the AP. So the access point that connects to the wired might receive a broadcast packet or a multicast packet on its Ethernet cable, and then depending upon whichever network it's received on, it basically forwards those packets out on those wireless LAN interfaces. So by default, again, we forward ARP and DHCP, but for both from wireless to wireless and wired to wireless. But if these two features are disabled, then traditional broadcasts are and multicast are all are not allowed on the WAP itself. So again, three things to keep in mind. One is the general broadcast multicast, which goes from the wire to the controller to the access point over the CAP/WAP tunnel. The second is the IGMP snooping, where you're much more smarter about handling multicast traffic, and that is a recommended way of handling multicast because you have a list of multicast groups that the stations are subscribed to, and at that point you basically that works in conjunction with the setting here where you say multicast to unicast is enabled and the multicast packet is discarded. This means that the original multicast packet that was received gets discarded, and now you turn around and just send unicast to those stations that have requested it. And then the other is the broadcast forwarding and multicast forwarding at the WLAN interface itself on the AP. So again, you have to be, by default, all this is disabled. You have to be very prudent about when you enable it, and and typically you will have to enable this in scenarios where you know that this particular SSID is going to see a lot of like AirPlay kind of traffic, or Roku or OTT boxes, where they need pairing from the mobile phone, where mobile phone is trying to share on a smart TV, which is also on Wi-Fi, things along that line. So just keep this in mind. That this setting goes on with that. But if you're just doing this for pure data purposes or voice only, I would rather keep this setting disabled. So that's my recommendation. All right, I hope that gives you a much better understanding of how broadcast forwarding and multicast forwarding works on Samsung controllers. And I hope I look forward to seeing you in the next video. Thank you.